Okay, in this video, I'm going to talk about how you can calculate your retirement sum if you were to put in a sum of money every month. Okay, so in this scenario, right, let's take it as an investment instrument that gives you 5% per annum. Okay, and then let's say it is compounded quarterly. Okay, so in such a scenario, and let's say you were to put in $1,000 every month. Okay. Okay, so it'll be quite interesting to see how much you will have when you are 95 years old. Okay, so every third month, okay, so right now we are going to set up the pattern first. Okay, so every third month you would have put in $3,000, right? And 5%, since it's compounded quarterly, each time is compounded, it is 1.25%, right? So that would be 3,000 times 1.0125, right? So at the end of the third month, you would have this much, right? This amount of money. And at the end of the 6th month, you would have 3,000 plus 3,000 times 1.0125. Okay, so this 3,000 is the next 3,000 that you've put in, right? From April, May, and June, for example. Okay, and then this one is actually from the initial 3 months. Okay, so you have this amount, and then this investment instrument is going to give you another 1.25%. So we're going to multiply this by 1.0125. Okay, so if you were to write it out, it should look something like this, right? 3,000 times 1.0125 plus 3,000 times 1.0125 squared. Okay, so if you continue doing that, okay, let's go to the 9th month. Okay, you should see that the pattern should look something like this, right? So you will get something like this. 3,000 times 1.0125 plus 3,000 times 1.0125 squared plus 3,000 times 1.0125 cube. Okay, so the pattern should be quite noticeable by now. All right, so you can expect, okay, so let's say, if I have, let's say, nth month, okay, the nth month would look something like this. Okay, the nth month would be 3,000 times 1.0125 plus 1.0125 squared, 1.0125 cube, all the way to 1.0125 to the power of n minus 3, right? So just take note that, if it's the 9th month, I'm going to have 3 terms, right? So you notice that I have 3 terms, 1, 2, 3, right? So this is actually a geometric progression, okay? And I will stop at power 3, which is actually 9 divided by 3, right? So that's the reason why I have n divided by 3 here, right? So the number of terms here would be n over 3, right? N over 3 number of terms. Okay, so let me just write down here. This is n over 3 terms all together. Okay, so this will be a GP. Okay, so it will be a sum to n over 3 terms. Okay, all right, so let's try that out. So for the sum of a GP, okay, let me just write down the formula, right? Sn, okay, is actually A times 1 minus Rn divided by 1 minus R, right? So A is the first term. Okay, A is the first term of the GP, and R is the common ratio. Okay. Okay, so N is the number of terms, all right? Okay, so in this case, what is the first term? The first term would be 1.0125. Okay, but let me just write the 3,000 in front first, okay? 3,000, okay, so the A will be 1.0125. Okay, and then this will be 1 minus 1.0125 to the power of n over 3, since they are n over 3 terms. Okay, and divided by 1 minus 1.0125. Okay, so we kind of got the formula already, okay? So if you were to continue and simplify this a little bit more, you should get negative 243 times 1,000 times 1 minus 1.0125 n to the power of 3, right? So that will be the general formula, right? In particular, you know, for this particular figure, right? So for 1,000 a month and 5% interest, okay, per annum, compounded quarterly, okay? So let's say, right? Let's say you have, you know, let's say you do it for 240 months. Okay, so that's 20 years, right? So let's say 240 months, right? Okay, so let's type into the calculator and see what's the value that we will get. Okay, so that is around 413,460.8406, right? So something there, something along this. So that's 400 over 1,000 here. Okay, so let's say you do it for 360 months. Okay, so that's 30 years, right? Okay, you're gonna get 835971.8146. Okay, and let's try it for 70 years. Okay, so 70 years, you should get 840. Well, that is quite a large amount, right? So that's 7.6 million, more than 7.6 million. Okay, so there you have it, right? So let's say you start doing this when you're 25, when you know start working, when you graduate from college, and you start investing 1,000 a month, you know. But provided you can find such an instrument that gives you 5% compounded, okay. So when you're 95, which is 70 years later, you're 95, you should have about $7.6 million, right, in this investment. And of course, depending on your lifestyle, you know, this may or may not be enough, right, for you. Okay, but it's just something for you to think about. Okay, so hopefully this video helps you in any way. I'll see you in the next one.